Okay, refractive index, here we go. So, state the advantage of shining the light at right angles into the prism. Right, okay. So, we've got this prism here. We're shining red light in at right angles and it's being refracted. So, state the advantage of shining in red light at a right angle there. Well, refraction is still technically taking place, okay? So don't write no refraction happens. It's just that when the angle of incidence is 90 degrees, then the direction doesn't change inside the glass, okay? So state the advantage of shining the light in, the direction doesn't change. Okay. Don't write it isn't refracted because technically it is. Okay. Suggest why the student uses light of just one colour. Okay. The reason is that the colour of the light depends on the wavelength, and different wavelengths are refracted by different degrees. Therefore, different colours are refracted by different amounts. So the advantage of using one colour is that if you are using white light, for example, which is a combination of lots of different colours, then you'd get one white ray in, but it would be spread out, you know, like on the Pink Floyd album cover. All the colours would be refracted by different amounts and you'd get a spreading out. But with one wavelength, one colour, you just get one clearly defined ray. Okay. State the name given to the line XY. Okay. Line XY, there it is. Well, that's quite simply called the normal, okay? You need to know that. At any glass interface where there's a ray, you need to draw in the normal. So if you like, you can put in a right angle there, because the normal by definition is at right angles to the boundary. Good. Okay. Measure the angle of refraction of the light at B. Okay, so you need a protractor for this exam or this question, and you have to measure the angle of refraction here. Now, what is the angle of refraction? Okay. You always measure angles of incidence and refraction between the normal and the ray, never between the surface and the ray, okay? So that means it's not that one and it's not that one, because that's between the surface and the ray. So the angles of incidence and refraction must be these two, between the normal and the ray, okay? Now, which is which? Well, this can lead to a lot of confusion in this topic, okay? How do you know which is the angle of incidence and angle of refraction? Well, in this question, okay, it says measure the angle of refraction of the light at B. Okay, this is where it gets confusing. So we're going to do a question in a second about refractive index, n is sine I over sine r. And when you're using that equation, okay, the angle of incidence should always be the bigger angle, the one in the air, right? But these exams, they ask you confusing questions like this one right now. Measure the angle of refraction of the light at B. Because the light's traveling this direction, it implies that the angle of refraction is this one. And that's what they want you to measure, this one, okay? Because it's being refracted here. So after it's being refracted, because it's traveling this direction, then that would make that the angle of refraction. But like I say, I don't blame people for getting confused over this, because when it comes to the actual equation, the angle of refraction is always the one inside the glass, which we'll talk about in a minute. So it's a very annoying feature of this topic, refraction, okay? But it's just something you've got to live with. So the confusing language saying measure the angle of refraction of light at B, it means this one, but I'm not going to label it R because I'm going to label it I in a minute. But again, just to go over this again, because it's so important, potentially confusing. Well, it is confusing. That's only the angle of refraction in this case because the light is traveling in that direction. So the way they've described it, that's the angle of refraction. But again, I want to stress for the equation, you would never use the external one in air as the angle of refraction. That's always the angle of incidence, no matter which direction it's traveling. Okay, so for the last time, it wants you to get your protractor out and on your exam question sheet, measure that angle, okay? And it turns out that it's 61 degrees. And apparently they allow you plus or minus 2 degrees in either direction, okay? Okay. Right. State the relationship between refractive index, angle of incidence, and angle of refraction. 1 mark. Okay? You've just got to know this off by heart, right? N, that's the refractive index, is sine I over sine R. Okay? Learn that right now. You need to know that. Okay? Refractive index is sine of the angle of incidence divided by sine of the angle of refraction. That's it. Okay. Right. The angle of incidence at B is 30 degrees. Okay. So they're telling us that that angle is 30 degrees. That's 61 degrees. Calculate the refractive index. Right. So, again, I'm going to keep banging on about this whole question because it's so confusing, okay? They've told you that the angle of incidence is 30 because the ray is travelling in this direction at this interface. That's the angle of incidence, the way they've described it, and that's the angle of refraction. However, like I said, when it comes to the equation, you should always put the angle of incidence as the one in air, the larger of the two, and the angle of refraction should be the one inside the glass, the smaller of the two. Okay? So that's what we're going to do. The reason is that refractive index should always be bigger than 1. Okay, so that for angles between 0 and 90, the sine of the angle is, if the angle is bigger, then the sine of it is also bigger. So that the angle of incidence should always be bigger than the angle of refraction. That's how to remember it, okay? Whichever's the bigger one, put it on top. And the bigger one will be the one in air. Okay, so let's do it. N is sine I. For the equation, like I said, I'm going to keep going on about this. Sine I is the larger of the two. So even though they've described it as the angle of refraction, for the equation, that is the angle of incidence, okay? It doesn't matter which direction the light's going. For the equation, the angle of incidence is the bigger one. So it's sine 61 divided by sine R. Refraction is the one inside, sine 30, okay? So sine 61 divided by sine 30 is 1.74923 something something something. Let's say 1 decimal place seems sensible. So let's 2 would be fine. So 1.721 dp. okay, because the 4 leaves the 7 alone. Okay, now, to show the examiner you know what you're talking about, just put in brackets that the refractive index should always be given from glass to air. Okay? If the ray were travelling in this direction, the opposite way it is in the question, then that would definitely be the angle of incidence, right? And that would definitely be the angle of refraction. So when that's the case, the angle of incidence is definitely bigger than the angle of refraction. That's what you should, the way around you should do it. And when you talk about refractive index of a substance, of a certain type of glass, okay, it technically means what's the refractive index from glass to air. So that's why they've deliberately made this question confusing. The direction of the ray in this question is not at least at B, at A it is, at B, the direction is from glass to air, not from air to... I meant air. I meant air to glass. You see, it's confusing. Air to glass. Okay, right. Refractive index should always be stated from air to glass. And like I said, I'll go over that bit again. If the direction of this ray were in this direction, then at B you would be going from air to glass. Here, okay? So state that, okay? Whenever you calculate the refractive index, state that you mean from air to glass, and they'll definitely give you the marks. But in this question, the ray is in this direction, so at B, the direction of the ray is actually from glass, at B, from glass to air, making things confusing. So in your answer, if you're ever asked to come up with a refractive index, make sure it's bigger than 1, okay? If it's smaller than 1, it's wrong. Refractive index must be bigger than 1 because the angle of incidence in the equation is the bigger one, okay? So no matter what the direction, angle of incidence, sine I, is 61, okay? So that's the way you should do it. Always make sure that the one on top is bigger than the one on the bottom. So that's incidence, that's refraction, okay? To work out refractive index of glass. It doesn't matter about direction. And state that that's a refractive index from air to glass, which is how refractive index is quoted, okay? Right, I think I've gone on about that enough. Okay, right. The critical angle of the glass prism is 35 degrees, okay? Critical angle C is 35 degrees. All right. Explain what is meant by the term critical angle. You may draw a diagram. 2 marks. Okay. So, if it encourages you to draw a diagram, definitely draw a diagram. Always draw a diagram. Well, not for maybe like a 1 or 2 mark question, but if it suggests drawing a diagram, definitely do one. But generally diagrams are good ideas, okay? Right, so let's have a glass block, all right? And a normal. And a ray of light leaving the glass block. So, angle is between the normal and the ray. Once again, doesn't matter about direction. The angle of incidence is always the one in the air. The angle of refraction is always the one in the glass. Okay? So write down the equation. N is sine I over sine R. This is only a 2-mark question, right? Yeah, okay, so I'm going to go into this in quite a bit of detail. This will definitely get you the 2 marks. All right. So just explain as briefly as you can that at some point, if you increase R, right, to the critical angle C, then the refracted ray will eventually hit this surface. It comes down here and hits the surface of the glass and will be going in that direction when the angle of incidence is 90 degrees. Okay, so that's the critical angle when that starts happening, and at that point it actually starts getting totally internally reflected. It reflects off this surface where at the same angle, so that would also be C. Okay, it's a lot for 2 marks, right? So the refractive index N is sine I, incidence is 90, so sine 90 is 1, okay? Bit of maths there. And sine R, well, the angle of refraction has become the critical angle, okay? So therefore N is 1 over sine C, or sine C is 1 over N, okay? So that's where it comes from. If you write that, that'll definitely get you the 2 marks, but that's the full picture, all right? Okay. Right. At angles inside the glass greater than C, total internal reflection occurs. Yes, okay. I just wanted to state that to finish off, to definitely get the 2 marks, you could write exactly what I just said. At angles inside the glass greater than C, the critical angle, total internal reflection occurs. And that's when this ray is reflected rather than refracted. Okay. Right. The student shines the light so that it hits B at a different angle. Continue the path. Okay. They've given us a little diagram, so I shall attempt to recreate that. So you've got some surface here. That's air, glass. Okay, it's coming in at, the ray is at 50 degrees. Well, take that back. That angle there is 50 degrees. But that's between the ray and the boundary. And what did I say? We're not interested in that angle. We always talk about angles between the normal and the boundary. So they're trying to trick you in this question. Well, maybe. Anyway. Okay. Normal there. Right. So, just got to continue the diagram. Now, they've told us that the critical angle for this, this glass is 35 degrees, okay? So, the critical angle refers to the angle inside the glass, okay? So that is not the angle, like I said. The angle of refraction, okay, inside the glass is the one between the normal and the ray. So if that's 50, that must be 40 degrees, okay? So the angle of refraction, again, ignore direction of this ray. Direction doesn't matter. Angle of refraction is always inside the glass. So the angle of refraction is 40 degrees. which is bigger than 35 degrees. So therefore, we're above the critical angle, so total internal reflection will take place. So this boundary will simply act like a mirror. So this ray will bounce off something like that, okay? Where that angle, label this as well, that angle is also 40 degrees, and therefore that angle is 50 degrees. Okay, I didn't draw that brilliantly, that should be slightly this way more, but it doesn't matter. You won't lose marks for that sort of thing, inaccuracy in your exam, as long as you've labelled it, okay? So that's it. If you want, you can say that total internal reflection is occurring. Does occurring have 2 R's? Don't think so. Could be wrong. Okay, good. Well, that's it, I think. Yep, I'll get you the 2 marks. Right. So, I'll just go over it one more time, okay? For the umpteenth time, because, like I say, so much confusion arises. When they're describing what happens in this topic of refraction, they sometimes, exactly like they did here, they set it up to be confusing. They said, measure the angle of refraction of the light at B. Okay? Now that's using language, not the equation. When in the language side of things, then they were referring to angle of refraction being on the outside. But again, I stress, that's language, not the equation. Okay? So that's the angle they were looking for. But when it comes to numbers and the equation, okay, ignore the direction of travel of the light. It doesn't matter, right? When it comes to working out refractive index, then the angle of incidence is always in the air and the angle of refraction is always in the glass. Just remember that and you won't go wrong. And if you remember that, you'll always get a value of refractive index that's bigger than 1, okay? So if your value of refractive index is smaller than 1, it's a warning you've made a mistake somewhere, okay? You've probably got it the wrong way up. Okay, that's it. I hope that hasn't confused you more than you already were. Okay, there we go. Thank you for watching. I hope you found this video helpful. If you did, please click the like button and it would be a massive help if you could subscribe. It would also be amazing if you could support me on Patreon. All the papers and everything are on my website, drgem.com, and I'm also on social media. Thank you.